Is it a solid?
Is it a gas? What could it be?
It's a liquid!
That's right, ladies and gentlemen. Me, Jonathan Roscoe, here presenting you this amazing product that's been around since the beginning of time. With my partners, R.E. Miller, Damian Whalen, and Sean Fitzpatrick. Without this product, you wouldn't be alive. This could be a gas, this could be a solid. It's the amazing, the incredible liquid.
If you're wondering what a liquid is something that has an indefinite shape and a definite volume. Definite volume because it has the same volume no matter what container you put it in. Indefinite shape because no matter what you do, it'll take the shape of the container.
An example of a liquid is water, which is made up of 1 part oxygen and 2 parts hydrogen.
One characteristic property of a liquid is viscosity, or a liquid's resistant to flow. A liquid's viscosity depends on the size and shape of its particles and the attractions between the particles. Some liquids flow more easily than others. Liquids with high viscosity flow slowly, like honey. And liquids with low viscosity flow very quickly, like water. Water and vinegar usually have relatively low viscosities, as honey has very high viscosity.
The lines on the ground represent a container. Our partners here are now moving freely, as a liquid molecule should, with a steady energy. They may not leave the container, moving freely, and they're not doing any change. You don't want to be a boring old solid molecule that the only thing he does is run in place. And you also don't want to be a psychopathic gas molecule that the only thing he does is just act crazy. Unless you want to be a liquid that moves freely in its container, with a steady energy that may not leave it, flowing and calm. I'm going to leave this cup full of water for a couple hours. We'll be back in a little bit.
Now see, the water is evaporated from the cup after a few hours of us playing football. And we come back, and as you can see, the heat, or the energy that came to the water, took the water out of it and formed it into water vapor, which is now in the gas state.
It started the evaporation process from the top, not the bottom and the top, like boiling. So all of the water dissipated from the top.
Surface tension, or the layer skin created by molecules when they push up on the surface of the water. It exists. If you don't believe us, we're going to put this paper clip over the layer of it. And as you can see, it floats on the skin, or the molecules pushing up to the surface. Now we're going to take this same paper clip and break through the skin, or the layer of molecules pushing up to the surface. And as you see, it sinks immediately to the bottom.
Thanks for watching!